Hello everyone, and welcome to the first video of this new channel, Coding with Jazz. In this channel we're going to be looking at different programming questions and challenges, and trying to come up with solutions to them. In this video we're going to be looking at this puzzle. So you have to twist the different rings around and try and get all of the balls of a single color lined up in one row. Okay, so the process we want to follow to solve this problem is we first want to come up with a robust algorithm that will solve the problem and with very concrete steps that we can tell to a computer. And once we have that algorithm, it shouldn't be that difficult to then turn it into a program. So the first thing we want to do for this algorithm is change the problem into something simpler that we could program into a computer somehow. So we can change it into a graph problem where every node is a slot on the cylinder where a ball could fit. And then like the black node would be like the lack of a node, the lack of a ball there, and then the colors on the nodes would represent the balls that are currently at that node. And then we have these edges along which the ball can traverse, and we see that this leftmost node has access to all the 4 different columns. And then in the middle of like one of the rings, we can only move back and forth since we're stuck on that ring. But between the 2 rings, we can twist the puzzle around so that we can access any of the other rows. So that's how we can come up with a network of to represent the problem, and then we have to break down this problem. And to do that, we're going to say that we can solve it 1 row at a time, and then if we do that 4 times, then we should solve the whole problem. And so we can say pick the second row and say we want to turn it all blue. So we already have the first one and the second one done, so we are going to lock them in place, and we're not going to touch them for the rest of the algorithm. And now we just have to get the third node in that row to be blue. So in order to do that, we need to find the closest blue ball that is available to get into that slot. So we can use the breadth first search to look around and find the nearest blue ball. So we look at all of the neighbors of this node, and we're completely going to ignore these 2 nodes over here that have already been solved because we can't touch them anymore. So we're looking at the neighbors to this node over here, and we see that there is indeed a blue ball right there that is just 1 edge away. And so now we just need to get this blue ball over here, but in order to do that, we need to move the empty slot over there to make room for the blue ball to go in. And to find the path of this empty slot to this spot over here, we're going to again use the breadth first search. So we're going to look at all of the neighbors again, but this time we don't find the node we're looking for, which is this one. So we have to go to a second level of the search. And so these are all the nodes that are a distance of 2 away, and we still haven't found our node, so we have to go to the distance 3 nodes, and we find that yes, it's there at a distance of 3, and we can kind of trace our algorithm back to see what steps did we take, and we get the path that this empty slot needs to take to get to this spot over here. So we can just move the balls to get the empty slot over there, and then move our blue ball in. And we can mark it as completed and move on to the next slot in the row. And now again, we're going to look around with the breadth first search and try and find a blue ball, the closest blue ball that we could move into that spot. So all these distance 1 nodes, none of them are blue, so we move on. Distance 2 nodes, none of them are blue again, so we move on to the third level. And we find a blue node over here, and we can trace back the path we took. Yeah, and a quick thing. So, yes, there are technically multiple paths that we could take to get to this blue node. But the way that you would program this, you would always have one path to every node that you get to, and so we could yeah, so then we can just follow that path back, and then we have the sequence of steps that this blue ball needs to take, and each of those steps will just involve moving the empty slot over there and then moving the blue ball in. So we can do that for the first one, and again, of course, we're using the breadth first search to figure out the shortest path to get there, but we can skip the details because we've already gone through it a few times. So we get the blue ball there, and then next we want to move the empty slot to spot number 2, and we can do that. And then finally we want to get to our slot number 3. So we move our empty slot over there and move our blue ball in. And we mark that as completed, and now none of these 4 balls can be touched again as we keep solving the problem. And to continue, we would move this blue ball over here eventually, and then pick a new row and a new color for that row. Turn all of those to that color, and then do that for the next 2 rows, and then we would solve the whole problem. Okay, so I wanted to talk quickly about the limits of this algorithm. So one of the limits is that this algorithm could actually get stuck. So if, for example, if we're in this case, we need to get the yellow ball all to the empty spot over here, but every other slot has already been solved. So this algorithm would not know what to do. So we would have to implement some sort of check for this and some resolution to this problem. And it's easy for us to see what should happen in this case, which is move all of the yellow nodes down 1, and then the ball can just slide in right there. So we could probably implement something like that into our algorithm. And then, of course, the second limitation of this algorithm is just that it's not going to give us the most efficient solution. It's just going to give a solution to the problem. I hope you enjoyed this video, and thanks for watching. Here are some of the other puzzles I have, and please leave a comment if you would like me to analyze any of these other puzzles. My plan for next time is to actually program this algorithm that we came up with today.